In this video, we're going to be talking about algebraic fractions. Specifically, we just want to simplify algebraic fractions, not solve equations involving algebraic fractions. That won't be until a little bit later. So we're just going to do one example. Hopefully you've already looked over several in the textbook. So we're going to be simplifying this expression in purple. Y minus 3 over y minus 5 squared minus y minus 2 divided by y squared minus 4y minus 5. And the first step in any problem like this is to make sure that each numerator and each denominator is completely factored. Okay, so y minus 3, that can't factor. Y minus 5 squared, that's already in factored form. We've got two copies of the factor y minus 5. Y minus 2, that's already factored, but this expression is not already factored. So we're going to start by factoring that. So we've got y minus 3 over y minus 5 squared minus y minus 2 over. Now it's possible in some problems to get an irreducible polynomial like this, which means that you can't actually further break it down, but I'm just telling you right now this one can factor. So if you want to practice, you may just pause the video and see how this factors, because we're about to go ahead and just plug this in directly. Okay, so this ends up factoring into y minus 5, y plus 1. And this is important because now we've got this term y minus 5 that shows up in both our denominators, and that simplifies our lives a little bit when we go to make the next step. So the next step is we need a least common denominator, which I'm just going to call the LCD. So algebraic fractions are no different than regular fractions. If you're trying to add or subtract fractions, you need them to have the same denominator. Well, right now this has two copies of y minus 5, this has one copy of y minus 5, and a copy of y plus 1. So what you're trying to do is figure out what needs to go into this common denominator that will cover all of these, and the least part of the common denominator means that it needs to be the smallest thing possible. And in general, the way you go about doing this is you can just look at the first denominator, and everything that's in the first denominator is going to have to be in the common denominator, because the common denominator has to have everything in this plus anything that's in any of the rest of the fractions. So we can look at that first denominator and see, oh, there's going to be y minus 5 squared. Check. We're going to have everything in this denominator. Then we go to the next denominator. Now, do we already have a y minus 5? Yeah, we've actually got two of them. Okay, so we don't need to add an extra y minus 5 for this. Now, do we already have a y plus 1? No, we don't. So we're going to have to add a y plus 1 to the common denominator. So this will be our common denominator. Now, because there's no equal sign in this expression, we're just trying to put these fractions together. What we want to do is multiply by, we want to multiply each fraction by its missing pieces. So what do I mean when I say pieces? I mean the pieces that it's missing to form the common denominator. And we want to multiply on the top and the bottom. And the reason we do this is because we can't actually change these expressions in terms of their value. We just want to change the way that they look. Okay, so what does this expression in green mean? So let's just go ahead and work this. So y minus 3 over y minus 5 squared. That was our first fraction, the one here. Well, what is this denominator missing, right? We've got y minus 5 squared. It's missing a y plus 1. So what we're going to do is multiply this fraction by y plus 1 on the top and on the bottom. Right? I mean, if we wanted to, we could just cancel these out. So this is the same as just multiplying by 1, which isn't going to actually change this expression. And that's really crucial, that we don't actually change the value of this expression. We just want to change the way that it looks. And then we do the same thing for the second fraction. So the second fraction here was this minus y minus 2 over y minus 5 times y plus 1. And now we need to multiply this fraction on the top and bottom by whatever it's missing from the common denominator. So this denominator has a copy of y minus 5 and a copy of y plus 1, so it's missing one copy of y minus 5, so that's what we're going to multiply this one i on the top and the bottom. And now when we do that, let me just go ahead and put these together into a common fraction. Now, it's also worth noting here, before I continue, that we don't actually want to multiply all these things out in the denominator. Okay, there's no real reason for us to do that. It's not going to actually make things simpler, and in fact, it's going to make things more complicated. So what we've done here is say that both the first and the second terms now have this as their common denominator, right? Because when you multiply fractions, you just multiply across the top and multiply across the bottom. So here we're going to have y minus 5 squared times y plus 1 in the denominator, and here we're going to have y minus 5 times y minus 5, so that's y minus 5 squared, also times y plus 1. And in the first numerator we have y minus 3 times y plus 1, and then we're going to be subtracting the product of y minus 2 times y minus 5. And I really strongly recommend that you keep this this minus sign separate from this term. It's sort of going to make your life easier to just flip all the signs at the end, I think. So I've put this in parentheses because this minus sign does apply to everything here. And so now what we have to do to finish up is actually do this multiplication and do this multiplication and then combine any like terms if we get any. Okay, so let's do this multiplication first. So if you remember from a few videos ago, when we multiply like this, you can either do the FOIL method, which we haven't talked about in one of our videos, but essentially the same thing is to break this first one apart and distribute it to each piece. So when we distribute this y to both y and y plus 1, we're going to get y squared plus y, right? Y squared, 1 times y is just y. And then when we distribute this second one, we'll get negative 3y and negative 3. And if you do the FOIL method, if you're familiar with that, this corresponds exactly to first, outer, inner, last. So it should be the same thing either way. And I'm just going to bring down this negative sign, and then I'm going to wrap all of what we get here in this product in parentheses. And so again, we just split this and multiply like we have done. So we'll get y squared minus 5y minus 2y plus 10. And all of that is going to be over our common denominator, which we are not changing in this step. It's just getting carried along for the ride. And in fact, we're not going to be changing this denominator for the rest of the problem. We just need to finish simplifying what's up here in the top. Okay. So now we need to think about combining like terms. So first I'm just going to consider this by itself and then consider this by itself. So are there any like terms in this expression? Sure, this positive y and this minus 3y, those can be put together, and they'll give us minus 2y. And then this stuff in the parentheses, the minus 5y and the minus 2y can be put together, giving us a total of minus 7y. And again, this is all going to be over our common denominator, which again we are not changing anymore. We just need to define this denominator so we could put the fractions together, and now we're just trying to simplify. Okay, and now the reason I recommended just carrying this minus sign along is because now that we've got this over here in the parentheses simplified, we're going to do what we did last video and just distribute this negative, which means that literally everything in those parentheses is going to get its sign changed. So this part in the front did not have any parentheses, so it just stays the same. But now that y squared becomes negative y squared, the negative 7y becomes positive 7y, and the positive 10 becomes negative 10. And again, all of this is going to be over our common denominator. Also, I know it's tempting for students to just not write this denominator in every step and just try and simplify the top and then put it over the denominator, but I don't recommend that you do that, especially on a quiz or a test, because what happens is students get in a hurry and then they forget to put this back in, and now suddenly all your work makes no sense with respect to the problem. So I really suggest that you just take the extra 5 seconds and write this denominator in every step. Okay, now we're almost done, and so we just need to combine any like terms if we have them in the numerator. And we do have a bunch of pairs, so let me just get some colors and we'll talk about which ones go together. Right, so we have this y squared and this negative y squared, and then we've got negative 2y, which goes with positive 7y, those are like terms. And then we've got this negative 3, which is going to go with our negative 10, those are like terms. So as soon as we put all of those together, then we'll be good to go. Okay, so starting with the green ones, y squared minus y squared. Okay, well those are just going to cancel each other out, right? And then negative 2y with positive 7y, that's going to give us 5y. And then negative 3 with negative 10, that's going to give us minus 13. And all of that is again going to be over this denominator that we haven't changed in several steps, our common denominator. Now when you get to this stage of the problem, you might check and see if your numerator can be factored. Sometimes it can. And for example, if we could factor this such that a y plus 1 appeared, then we could just cancel those y plus 1s. However, this one can't be factored, right? So there are only two terms and they don't have anything in common and they're not a difference of squares. So we can't actually factor the numerator in this problem, so this is going to be our final answer. And again, it's important to note here that this was just adding or subtracting algebraic fractions, not actually solving equations using algebraic fractions, because those problems are going to look very similar to the one that we just did, but there's going to be a crucial difference. So this was for just putting together fractions, not solving equations, but just putting them together.